All right, welcome back to our energy unit. We are in lesson 11 today, where we're talking about thermal energy transfer. In lesson 10, we talked about heat and temperature. That was sort of our introduction to heat energy. We talked about how heat and temperature are not the same thing, but they have an impact on one another. So let's do a quick review, and then we'll jump into heat energy transfer. So, by definition, remember temperature is directly related to how much kinetic energy an object has. If an object has a lot of kinetic energy, chances are its temperature is going to be higher. And if an object has very little kinetic energy, it's going to be very low in temperature. So, even though temperature is a measurement and thermal energy is a form of energy, they do have an impact. So as heat energy increases, temperature increases, and vice versa is true as well. And so we looked in the last lesson at several examples of this. So if you'll also remember in lesson 2 in the unit, we talked about the law of conservation of energy that says energy is not created or destroyed, but it can change from one form to another. Heat energy sort of follows the same guidelines in that it can move from one object to another. In fact, it happens a lot. So heat energy will move when you have two comparative objects of different temperatures. Heat energy will always move from one object to another in a predictable way. So the question, where does this heat energy go? Well, it goes to other objects that are different temperatures. And we know that it's not lost because we know the law of conservation of energy says that energy can't be lost. It can't be created or destroyed. And it can't disappear, but it can move from one object to another. So if you are in class with me, or if you missed class, you just need to know that we did some experiments where different lab groups got some different comparative objects. These objects were different temperatures, and we just kind of tested to see what would happen in different situations if you got two objects of different temperatures in the same vicinity. What happens with regards to heat energy? And so forgive my drawing. I'm not an artist, but we can tell kind of what happened. So one of our lab groups got this situation, and I just kind of made a sketch of what they noticed. So the situation that they received is a cup of warm water is placed in the fridge for an hour. So if we wanted to create an experiment to see what happens in this case, we could take a cup of warm water, like a coffee cup, and put it in the fridge or the freezer. So what we have done is we have taken an object of higher temperature, and you can see here that the temperature of the coffee cup is 65 degrees Celsius. If we put it into a colder environment, and we know it's colder because we see the temperature of the refrigerator is 10 degrees Celsius, what we know is going to happen is eventually I'm going to open up the refrigerator, and I'm going to notice that my cup of what used to be warm coffee is now going to be the same temperature as the refrigerator. So if you'll look at the bottom, the results that we got from this experiment, we noticed that after an hour, the refrigerator temperature was 35 degrees Celsius. So it was 10 degrees Celsius. It increased to 35 degrees Celsius. And then my cup of what used to be warm water is also 35 degrees Celsius. So it actually decreased in temperature. So because those temperatures are the same, the fridge temp and the water temp, we say that it has reached equilibrium. So that's a word that we discussed after we did these experiments. And I want you to notice in my drawing, in my cup of warm coffee, I actually drew arrows moving out of the warm cup of coffee or warm cup of water to indicate that heat energy does move from the warmer object to the cooler object, cooler being my refrigerator. And what that did is that increased the temperature in the refrigerator because it gained heat. And then because my cup of water or cup of coffee lost heat energy, that temperature decreased, and this continues to happen until equilibrium is met. So from those situations and investigations, we had several lab groups that had different situations, and what we found out is no matter what the situation, the same principle works in all situations. So what we came up with is we were able to fill in this blank. So you see where it says task, fill in the blank. Heat always travels from the blank temperature object to the blank temperature object until equilibrium is met. So I'm going to go back to my picture and we can fill in the blanks. Heat is always going to move from the higher temperature object, which in this case was my coffee cup, to the lower temperature object, which in this case was the refrigerator temperature, until equilibrium is met. And so we can see that happening in our results. Same thing happens if you hold, let's say you hold a piece of ice in your hand. What you'll notice after 5 minutes is that ice is going to begin to melt, and it's going to continue to melt until the puddle of water that's in your hand is the same temperature as your body. So your body has heat. That heat energy is going to move from your hand to the ice. It's going to increase the temperature of the ice and cause it to melt. It's going to decrease your body temperature. That's why your hand feels cold when you hold something cold. And that's going to continue until equilibrium is met. And eventually, the ice that you're holding will melt, turn to liquid water, and that liquid water will be the same temperature as your body. So this is what you need to write in your notes. The flow of thermal energy can move from one object to another in a predictable way. And here is the predictable way. Heat always flows from the warmer or the higher temperature object to the lower temperature object. So you can see in this top example, if I'm holding a hot cup of hot chocolate, I'm going to feel warmth on my hand because the heat is going to move from the higher temperature hot chocolate to my hand. If I hold a cold piece of ice in my hand, the heat from my hand, the higher temperature object, is going to move to the ice cube, which is the lower temperature object. And it's going to, because the heat's leaving my hand, I'm going to feel that as a cold sensation. So heat always travels from the higher temperature object to the lower temperature object. That completes the lesson over thermal energy transfer, and I will see you in the next heat and energy lesson where we talk